Have you ever wondered how welding hoses are made to ensure safety and efficiency in industrial processes? Today, we'll take you inside a Korean factory, specializing in the production of rubber hoses, a meticulous, high-tech process that involves precision and rigorous quality control. Let's get started. It all starts with the careful selection of raw materials, a fundamental step to ensure that the final hose meets the quality standards required by the industrial sector. The rubber used in the process can be natural or synthetic, depending on the specific needs for resistance, durability, and flexibility. Natural rubber, extracted from rubber trees, has excellent elasticity and wear resistance, making it an essential component for ensuring the flexibility of hoses. Synthetic rubber, developed from petroleum derivatives, has improved characteristics, such as greater resistance to chemicals, high temperatures, and abrasion. The combination of these two types of rubber is carefully studied to provide the ideal balance between flexibility, thermal, and mechanical resistance. After selecting the raw materials, the rubber undergoes a controlled heating process, where the temperature gradually increases to soften the material and allow the incorporation of chemical agents that improve its properties. This step, called mastication, transforms the raw rubber into a homogeneous mass that is easier to work with. The rubber is then mixed with special components, such as carbon black and plasticizers, which play a key role in the final quality of the hose. Carbon black, a very fine carbon powder, improves the mechanical and thermal resistance of the rubber, while plasticizers provide greater flexibility and prevent the material from drying out over time. In addition to these additives, other elements can be incorporated into the mixture, such as antioxidants, which protect the rubber against degradation caused by oxygen and sunlight, and vulcanization accelerators, which ensure uniform and efficient hardening of the structure. This mixture passes through high-precision cylinders and mixers, where all the components are integrated homogeneously, ensuring that the rubber meets strict quality standards before moving on to the next stage of the manufacturing process. After being extruded, the hose's inner tube undergoes a cooling process, which hardens it and maintains its precise dimensions. This step is crucial to ensure that the tube maintains its shape and strength throughout its useful life. But the process doesn't end there. Before moving on to the next stages, the extruded tube undergoes rigorous quality control. Specialized sensors and cameras analyze its thickness, diameter, and texture to detect possible imperfections. If any irregularities are found, the material is discarded or reused in a controlled manner. In addition, some manufacturers carry out specific tests to assess the resistance of the rubber under high pressure and temperature. This verification ensures that the tube can withstand the demanding conditions of the welding process, avoiding risks such as cracks, leaks, or premature wear. With the hose's inner tube approved, it is ready to receive the external reinforcement and protection layers, which will ensure even greater strength and durability of the final product. To ensure that the welding hose can withstand high pressures and continuous use, a fundamental step is structural reinforcement. This reinforcement is made with layers of polyester yarn or metal wire that are braided around the rubber tube. The addition of these materials significantly increases the resistance of the hose, protecting it from deformation and ensuring that it remains functional even in extreme conditions. The precise interweaving of the polyester yarn or wire around the rubber tube is crucial to ensure that the hose can withstand constant pressure and wear, without compromising safety during operation. This braiding process is carried out by highly specialized machines, which guarantee a rigorous quality standard in each unit produced. The braiding pattern may vary depending on the resistance requirement, but in all cases, it aims to create a homogeneous structure that is capable of distributing pressure evenly throughout the entire hose. the resistance provided by the yarn. Reinforcement allows the hose to be flexible without losing its ability to withstand high internal pressures. This is especially important in the context of welding, where hoses are exposed to severe conditions such as high temperatures and pressures during the work process. Reinforcement helps to prevent the hose from deforming or suffering damage that could compromise gas conduction. Thanks to the braided wire reinforcement, the hose maintains the flexibility necessary for easy handling, but with the robustness to withstand extreme conditions of use, ensuring safety and efficiency. After braiding, the hose moves on to another stage of the process, where the external covering is applied. However, before reaching this stage, it is essential that the reinforcement be tested to guarantee its durability. Tensile tests and pressure tests are carried out to ensure that the braided structure can withstand mechanical stress without failing. These tests are essential to validate the quality of the product and ensure that it meets the standards required by the market. Finally, the structural reinforcement, together with the external covering and the internal layers, ensures that the hose has a long lifespan and is able to withstand constant use, even in rigorous working conditions. This is one of the reasons why Korean welding hoses are so renowned for their strength and superior performance. With the reinforcement applied, the hose is able to withstand extremely high pressures and continuous wear, maintaining its integrity and performance for much longer. This braiding process, as technical as it is essential to ensure that each hose is reliable, safe, and able to meet market demands, especially in industrial applications that demand quality and efficiency. Now we come to the last step in the welding hose manufacturing process, the outer coating. After the internal structure has been reinforced and tested, it is time to apply a new layer of rubber over the hose. This layer has a fundamental function: to protect the hose against external agents that could compromise its performance and durability, such as oil, flames, and abrasion. The outer layer acts as a barrier, ensuring that the hose remains intact even in harsh industrial environments. The last step in the process is the outer coating. A new layer of rubber is applied over the reinforced structure, protecting the hose against external agents such as oil, flames, and abrasion. After the outer coating is applied, the hose goes through a crucial vulcanization process. During vulcanization, heat is applied to the rubber, activating the chemical components present in it. This process makes the rubber harder and more resistant, acquiring the flexibility and resistance necessary to withstand extreme working conditions. After application, the hose undergoes a vulcanization process, where heat activates the chemical components of the rubber, ensuring its final strength. Vulcanization is essential to ensuring that the rubber has a long service life. The heat causes the rubber molecules to intertwine, creating a strong molecular network, which not only increases the resistance to heat and pressure, but also improves the flexibility and durability of the final product. This process is key to ensuring that the welding hose is reliable and can be used in a variety of industrial applications safely and effectively. After vulcanization, the hose is tested once more, this time to ensure that the coating is fully adhered and that all the desired properties are present. This ensures that the final product is of high quality, ready to face the challenges of daily work, with full protection against the external elements. With the outer coating applied, the welding hose enters the final stage of production, vulcanization. This crucial process uses heat to activate the chemical components of the rubber, ensuring that it becomes even stronger and more durable. Vulcanization causes the rubber molecules to intertwine, forming a strong and durable molecular network. This intertwining gives the hose the characteristics it needs to withstand high temperatures, high pressures, and wear caused by abrasion. After application, the hose undergoes a vulcanization process, where heat activates the chemical components of the rubber, ensuring its final resistance. During vulcanization, the rubber becomes more flexible and resistant, which is essential for continued use in harsh industrial conditions. Resistance to oil and flames is increased, as is its ability to withstand pressure without suffering deformation. After this process, the hose is tested to ensure that all safety and quality properties are met. This final step ensures that the hose is ready for use, offering maximum protection and performance in any welding environment, ready to withstand the challenges of heavy work with efficiency and reliability. And this is how a high-quality welding hose is manufactured. From the choice of materials to quality control, each step is essential to ensure a safe and efficient product. Now that you know the process, you can appreciate even more the technology behind this essential item for the industry. Thanks for watching until the end. I hope you enjoyed it. Don't forget to subscribe and comment. See you next time.